So good afternoon. We're going to work with what's called point slope of a linear equation. So yeah, another form. So we talked about slope intercept form. We talked about standard form. There's also a slope what we call a point slope form. So remember, slope intercept form. We have the condition of we have the equation y equals mx plus b, where again m represented the slope and the b represented the y-intercept. And remember, we use that information to graph the linear equation. Standard form, ax plus by is equal to c. Remember that a, b, and c had to be integers, and we wanted that a to be a positive integer, to be a little more specific. Point slope form takes on this look. Y minus y1 is equal to m times the quantity x minus x1. So this is what they refer to as point slope form. In this, x1, y1 represents the point. So that's going to be the given point. And of course, m is the slope. So in this problem, x1, y1 is going to represent the point that was given. That's the point that the line actually passes through. And then m will be actually the slope of that line. So, now where this comes from, remember this is our slope formula. M is equal to the change in y over the change in x. y2 minus y1 over x2 minus x1. If you recall, we could make this look like a proportion by putting this like m over 1. And we know with proportions you're allowed to cross multiply. So I got 1 times y2 minus y1. Well, 1 times y2 minus y1 would just be y2 minus y1. And then here we have x2 minus x1 times m. So I can write that as m times the quantity x2 minus x1. Now to have a linear equation, we have to have this input-output thing. So we need to have our x and our y here, if you will. So what they do is they just make this become then y minus y1 is equal to then m times x minus x1. And you're going to be able to input into the x and y's there to verify other points. So here's going to be our information. So we're going to be trying to write a linear equation. The linear equation we want has to pass through this point, and it's got to be parallel to this line. So if I sketch that out a little bit, we know -3 would be -3 would be about here. We know that the given line, we have a y-intercept of 3, and it has a slope of 7/3. So the slope means from this point you can rise up, or actually, so I can actually go down as well. So I can make that a negative and a negative. So I can rise down 7 and run over 3. Oops. Yeah. So it looks like our line is going to look like this here. So what we're trying to do is write an equation of the line that passes to that point and is parallel to the given line. So the only thing we need out of this line is really just the slope. So that slope is at 7/3. And we have this given point of -3, -3. So to be in point slope form, I pick up on that x1, y1 is the given point. My slope is actually going to be the slope of this line because since they're parallel, our slopes are the same. So I can actually use this same slope for the slope of my line. So my slope is going to be 7/3. So I'm going to use this information and substitute it into the point slope formula to write our point slope equation. So I have y minus a negative 3 is equal to then 7/3, because m is 7, or m is going to be about 7/3. Then I have x minus, again, a negative 3. Now, we really don't like this a negative and a negative, so it's probably a good idea to write that as y and a positive 3 is equal to then 7/3 is equal to then x and a positive 3. So that would be our point-slope form of that equation. So to do point-slope form, you just need to know what the slope, what the point is, and also what the slope is. And once you have that information, it really just becomes just substitute in, and that's pretty much all there is really to do that. Might have to do a little bit of cleaning up, because we don't like to have two negatives there. Usually we write that as a plus. So we may have another example of that, so let's see what else we have there.